Hello, welcome to your first flipped classroom video. Today we're going to be discussing section 1.1, variables and expressions. So I would suggest that you write that at the top of your notes so that you know what this whole section of notes is really about. Make sure that you are writing down any of the important things that you see on the screen. You don't necessarily have to write the learning targets. Those will be in a sheet that's provided for you. So today, the goal of this video is for you to be able to interpret parts of an expression. This means that you will be learning how to explain how the parts of an expression relate to a real world context. So real quickly, an expression is a mathematical phrase. So you might want to write that down in your notes, just so that you know when you think the word or you hear the word expression, you think mathematical phrase. And we're going to be talking more about what that is. So let's concentrate on writing the verbal form. So we're going to learn how to take kind of a mathematical phrase and put it into words, and then we're going to talk about taking words and putting those into a mathematical phrase. So here we want to write what is the operation that's shown in each equation. Is it addition, subtraction, multiplication, or division? So here we have multiplication. Here we have, right here, subtraction. And here we have division. And this here, 13 plus 7, is addition. So what is an algebraic expression for 18 more than n? 18 more than n. How can we take and translate that into mathematical phrase or an algebraic expression? So first we need to talk about kind of how we take some words and put them into mathematical symbols. So more than, that operation would be addition. If you see less than, that is subtraction. Sum, the sum of two numbers, is addition. Fewer than a number, fewer means subtraction. So 18 more than a number n. Well, we have more than, so more than we've already established is addition. So we have 18 plus n. Here we want to complete each sentence with add, subtract, multiply, or divide. One word is used more than once, so let's figure this out. The phrase 8 less than a number tells you you need to subtract 8. The product of a number x and 4 tells you you need to add x and 4. The quotient of 6 at a number tells you you need to divide 6 by x. That would look like 6 over x is another way to write that. The phrase n times 12 tells you that you need to multiply n and 12. And the phrase the sum of a number n and 59 tells you to add n and 59. So let's take a look at this problem. 5 less than a number c. So less than for us, we know we've got subtraction here. My writing isn't the greatest. That I'm sure will get better. Okay. 5 less than a number c. So I have some number c that is some amount, and I'm going to take 5 less than that. So we have c minus 5. 8 less than the product of x and of a number x and 4. So we have two different operations going on here. We have subtraction and we have multiplication. So we have 8 less than the product of a number x and 4. Well, x and 4, these are the two things that are being multiplied. So I have x times 4. We usually write that as 4x. And I have 8 less than that. It's kind of that odd thing where it's not really 8 minus 4x. It's 8 less than 4x. So the less than goes over here. Let's look at this problem. 9 plus, what does plus tell you? When you see plus, we need to think addition, plus the product, that's multiplication, of 2 and a number d is 19. Is always is that equal sign. So now we're not just going to get an expression, but we're actually going to get an equation. An expression does not have an equal sign. It's just a mathematical phrase, and an equation has an equal sign in it. So 9 plus the product of 2 and a number d. So how do we write the product of 2 and a number d is 2 times d is equal to 19. So we have 9 plus the product of 2 and a number d is 19. The way to write that in the mathematical form or as an algebraic expression or equation in this case, is 9 plus 2d is equal to 19. So the sum means addition, of 11 and x to the third power is equal to, right here they tell us exactly that we have to put that equal sign in there, is equal to 38. So let's put this in mathematical terms. The sum of 11 and x, well, we're adding those two things together, so we have 11 plus x. Oh, and let's not forget, this x is to the third power. So let's put that exponent up there, is equal to 38. 11 plus x cubed, or x to the third power, is equal to 38. Here we have a real-world application. Suppose you draw a segment from any one vertex of a regular polygon to the other vertices. Now let's make sure that we understand this problem. It's talking about a vertex and a regular polygon. A regular polygon is any multi-sided figure where all the sides are the same length. And a vertex is this little point right here. And see, this one happens to have several of them. So we're going to draw a segment from one of the vertices or points to another and see how many triangles we can get in here. So a sample for a regular polygon is shown at the right. This is a regular hexagon. Use the table to find a pattern. Then we want to know, what is the rule for the number of non-overlapping triangles formed? So we have to write the rule. We're going to give that rule in words and as an algebraic expression. So those are the two things that we have to accomplish. So let's use a table. Let's start with a polygon with 4 sides. So here's my 4-sided polygon. Let's see, 4 sides, all the sides are the same. That means it has to be a square. So now if I draw from one vertex to another, I get 2. Okay, well what if I draw it the other way? What if I go from this vertex to this vertex? I get 2. So if I have a 4-sided polygon, I get 2 triangles. Let's try 5-sided. 1, 2, 3, 4, 5. Okay, it's not the best, but it'll do. So I have 5 sides. Well, I'm going to draw from this vertex to an opposite, and this vertex to an opposite. That gives me 3. I wonder if it would be any different if we draw it the other way. So let's see, let's start from here. There's 1, 1, 2, 3. So if I have a 5-sided polygon, I get 3. Now let's see with 6. That's our hexagon up here. So I have 1, 2, 3, I have 4 of them here. So if it's 6-sided, I get 4. And if it's 5-sided, I get 3. And if it's 4-sided, I get 2. Seems like it's 2 less than the number of sides. So we can give a rule in words to find the number of non-overlapping triangles in a polygon. So let's see, our rule here was that we took the number of sides of the polygon and we subtracted 2. So let's see, the number of sides and subtract 2, because that's what we did. So the last thing that we have to do is we just have to write this as an algebraic expression. That means we need to throw some variables in there and put what the mathematical operations are. Here it's actually telling us to use n for the number of sides of the polygon. So the number of sides, that'll be our n, and subtract 2. There you have it. There's our algebraic expression for finding the number of non-overlapping triangles in a polygon that has n sides, n minus 2. Now we're here at our lesson check. This is where you want to stop and pause the video. You want to try all of these problems. And when you come into class the next day, tomorrow, or whenever our class happens to meet, we'll go over what all those answers are and if you have any questions. Remember, don't forget to do your WISC. So now you've watched the video and you've taken notes. Make sure that you answer the summary questions. Use full sentences. Don't slack on that. And then you have to come up with one question, something that you didn't quite understand, or a question you think that you know the answer to that maybe somebody else won't. So make sure that you have those done, and we'll see you in class next time.